Welcome everybody to Exponents and Radicals Lesson 2. Let me pull out my drawing tools here. So we are starting our unit with Lesson 2. We did Lesson 1 on Friday a little bit, and we got a little bit of review there. So today we are starting radicals. So this is going to be kind of the theme of our first week and a half or so. So let's do a quick review. So on Friday we looked at square roots and cube roots. So we know with a square root that all positive numbers have square roots. You can't square root a negative number. The positive square root, so one positive number and another negative number. The positive square root is called the principal square root and is denoted by the symbol, bam, just like that, square root. So what they're saying is this down here is kind of your example. The square roots of 16 are 4 and negative 4, but when we write it, the square root of 16 is 4 only. So we know that 4 times 4 is 16, and negative 4 times negative 4 is 16. So the square root of 16 is 4. That is what is called a perfect square. So that means when we take the square root, it comes out to be a whole number, or an integer, or I guess in this case just a whole number. The square roots of non-perfect squares are irrational numbers. So we know square root of 17, if you type that in your calculator, it's going to give you some crazy decimal 0.1 something something that'll go on forever, right? It's non-repeating, non-terminating, so it's an irrational number, which is everything that's not a perfect square is a non-perfect square, and non-perfect squares are irrational numbers. So then we bumped it up to cube roots. So square root we know is that symbol right there. Cube roots is the same symbol, but with a little 3. So square root, it is a little 2 right here, but it's kind of implied. We don't have to write it down because we assume that when we draw that symbol that it's a square root, unless there's a different number written, like right here. What is happening? There we go, right here, for a cube root. I'm very technologically challenged, so that's going to happen a lot where something doesn't seem to be going right for me, but that's okay. It makes the videos a little bit more fun. So in the case of cube roots, all numbers, positive and negative, have one cube root, denoted by the symbol right here. That's the one I just wrote on the left side there. So we know that from a square root is a number multiplied by itself twice. 4 times 4. A cube root is 16, so then obviously the square root of 16 is 4. A cube root is the same thing, but 3 times, right? So it says here the cube root of 1,000 is 10. So it shows you here cube root of 1,000 is 10, which means that if you multiply 10, there we go, technologically challenged, 10 times 10 times 10, you will get 1,000. Same thing with cube root of negative 27 is going to give you negative 3. So negative 3 times negative 3 times negative 3 is negative 27. Or the cube root of negative 27 is negative 3. And the cube root of a non-perfect cube is an irrational number. It'll give you a non-repeating, non-terminating decimal. So we are going to go to higher or larger roots. So you can see 4 times 4 is 16. So the square root of 16 is 4. Or the square root of 16 is 4. Then we go to the next one. 5 times 5 times 5 is 125. So the cube root of 125 is 5. Or we can write it as the cube root of 125. Come on. There we go. Is 5. Oh man, this pen is already being a pain in the butt. But we can go up to the fourth root, right? Even even higher, and you can go up to 5th root, 6th root if you want to. So 2 times 2 times 2 times 2 is equal to 16. So the 4th root of 16 is going to be, that pen doesn't want to switch today, 2. And they wrote it here, the 4th root of 16 is going to equal 2. And then you can do the same thing for higher ones. Here we go. 10 times 10 times 10 times 10 times 10 times 10. So that's 6 times, right? 1, 2, 3, 4, 5, 6 is equal to 1,000,000. So the 6th root of 1,000,000 is 10. It says here, mentally evaluate where possible using the real number system. So this can be a little bit tricky sometimes. It's good to memorize the perfect squares and the perfect cubes chart that we looked at on Friday. It's going to help a ton with this. So 49, the square root of 49 is 7 because 7 times 7 is 49. This is the cube root of negative 64. If you memorize your chart, it's going to be negative 4 because negative 4, let's see if I can do this without messing anything up. Negative 4 multiplied by negative 4 multiplied by negative 4 is equal to negative 64. The 4th root of 10,000, there's a little trick with the like powers of 10, right? 10, 100, 1,000, 10,000. If you're taking the 4th root and there's 4 zeros, 2, 3, 4, the answer is going to be 10, right? 10 times 10 times 10 times 10 is going to equal to 10,000. The 5th root of 1 over 32. So you can think of this as the 5th root of 1 on the top, which will just be 1, and the 5th root of 32. 32, so the 5th root. So we're trying to find something that multiplies by itself 5 times to get to 32. So 2 times 2 times 2 times 2, you need to check that. 2 times 2 is 4, times 2 times 2 is 4, times 2. 4 times 4 is 16, times 2 is 32. So that works. The 5th root of 32 is just 2, so the answer is 1/2. You cannot take an even root of a negative number. So if you're trying to take an even root of a negative number, it is not possible. So any even root follows the same as the square root, right? You can't take the square root of a negative number. You can't take the square or the 4th root of a negative number. You can't take the 6th root of a negative number. But that's okay. As long as you remember that, you're good. And then in this case, this is like saying 2 multiplied by the 3rd root of 125. And if you remember your cube root, if you remember your cube root chart, you know that cube root of 125 is just 5, and 2 times 5 is 10. So there's your answer. Let's go to the next page. So this just talks about how to punch this into your calculator. So there's this button right here. Most calculators have it. It looks like a square root, but it's got a little X there. So now when you go to type that in, so if you were to type this equation in to your calculator, you would hit 4. Then you would find a way to enter that that X square root sign. It usually is pretty short. And then you could say 10,000 and hit equals, and that'll give you your answer. So what's happening is that number you put first is getting subbed into where that X is. So if you wanted to do the 5th root, you would type 5 and then your X root button and then whatever you wanted in there. 32,000. I don't know. I just made that up. So use your calculator. Try to evaluate some of these. I'll let you figure that out. It's just typing into your calculator, so you should be good. Radicals. So this whole unit is on radicals. So numbers like the square root of 30, the cube root of 125, the fourth root of 15, and the sixth root of a million are all examples of radicals. So any expression in that form, n root x, where n is all natural numbers, is called a radical. Natural numbers means 1, 2, 3, and up. Where n is called the index. So here we go. Here's a good example right here. The index is the small number there. The radical sign is obviously that guy right there. And the number underneath is called the radicand. The entire thing is the radical. So each piece has a name, and then the entire thing is called a radical. And then you notice that here is just a little reminder when the index is not written in the radical. So the small number, as in a square root, it's assumed to be 2. So if you just saw this, then you would assume that is the same as the square root of 81. They don't write the 2, it's implied. The index is the number of times the radical must be multiplied by itself to equal the radicand. It's just really wordy, but I think hopefully it makes sense. So identify the index and the radicand of each of the following. I'll do a couple and then I'll let you go through that if you want. So the index in this case is the small number, so that'll be 5, and the radicand is the big number underneath, so that's 75. In the next case, we see the square root sign, and there's no number there, so that means the index is going to be 2, right? We assume that there's a 2 there, and the radicand is 50. And in the next case, the index is always the small number. We don't worry about that 5. That's just another term. So the index is 3. That's a cube root of the radicand, which is 1 over 10. So hopefully on Friday we got to the point where we saw when we multiply root 9 multiplied by root 4, it's the same as the root of 9 times 4. Same thing with division. The root 9 divided by root 4 is equal to the whole root of 9 divided by 4. And then we hopefully figured out as well that root 9 plus 4 is not equal to the root of 9 plus 4, and the root 9 minus root 4 is not equal to the root of 9 minus 4. So this only works for multiplying and dividing roots, this combination of the two there, amalgamating them. So there's a really nice, right here, there's a nice way to summarize that. So the root of a times the root of b is equal to the root of a times b, and the root of a divided by the root of b is equal to the root of a divided by b. So it says here, state whether each statement is true or false. So we have the root of 3 times the root of 6 is equal to the root of 18. So we know that we can rewrite that as, let's scroll up here so it's at the top of my screen. We can write that as the root of 3 times 6, and then 3 times 6 is 18. So that must be true. The root of 20 over the root of 10, you can rewrite that as the root of 20 over 10, and we know 20 over 10 is 2. So that's also true. And then the root of 16 plus 9 is split into the root of 16 plus the root of 9. That doesn't work, right? Because the root of 16 plus 9 is the root of 25, which we know the square root of 25 is 5. The root of 16 is 4. The root of 9 is 3. So that equals 7. So this obviously 5 doesn't equal 7, so this is false. Write the following as a simple radical in the form root sign of x. So do they want just one term under the root sign? So here we're just combining. This can be written as the root of 8 times 3 or the root of 24. This one can be written as the root of 21 of 7 times 3. The root of 50 divided by the root of 10, so that is the same as the root of 50 divided by 10, which can be written as the root of 5, right? 50 divided by 10. And then in this case, this one's a little bit weird. We have the root of 100 all divided by the root of 2. So the first thing you want to do is just deal with this square root 100 here. So that can be rewritten as, well, the root of 100. What's the root of 100? The root of 100 is, the square root of 100 is 10. So I can just change that into a 10. And now I have the root of 10 divided by the square root of 2, which is the same thing as the square root of 10 over 2, which is the same thing as the square root of 5. And then we're going the opposite way. So now we've got a singular square root, and we want to express it as a product of radicals. So in this case, 77 can be split into 7 times 11, which then can be written as square root of 7 multiplied by the square root of 11. 27 can be split into 9 times 3, and then we can write that as the square root of 9 multiplied by the square root of 3. And then with 40, there's multiple different combinations you can do. Whoa, what happened? Oh, I went all the way to the bottom. I'm sorry, guys. I'm terrible at these videos, but hopefully they make sense. That's the biggest thing. Sorry, I gotta scroll through all of our lessons. 1 second, we're almost done. This is our last practice question. So the square root of 40, here we go, can be split multiple different ways, right? We know that 2 times 20 equals 40. We know that 4 times 10 equals 40. So all of them are going to be correct. So we can say this is the square root of 4 multiplied by the square root of 10. If you wanted, or you could say the square root of 2 multiplied by the square root of 20 if you wanted. Awesome. That's it for the video. Hopefully that wasn't too painful. I will slowly get smoother at them. And make sure you watch lesson 3 as well, which is the next video for Monday. Thanks for watching.